What is the difference? Specific heat versus molar heat capacity. Imagine you're trying to heat up a cup of water and a large pot of water. Both need heat, but they don't require the same amount of energy. Why is that? Today, we're going to find out the difference between two important ideas in thermodynamics: specific heat and molar heat capacity. These properties help us understand how different materials respond to heat, but they do it in slightly different ways. Let's start with specific heat. This is the amount of heat needed to raise the temperature of 1 gram of a substance by 1 degree Celsius or Kelvin. Think of it as how much energy it takes to warm up a tiny piece of something. For example, water has a high specific heat, meaning it takes a lot of heat to warm just 1 gram of water by 1 degree. Specific heat is an intensive property, which means it doesn't change no matter how much material you have. Whether you have a small spoonful or a large bucket of water, the specific heat stays the same. Its units are joules per gram per degree Celsius. Now, molar heat capacity is a little different. Instead of focusing on 1 gram, it looks at 1 mole of a substance. A mole is a fixed number of particles, about 6.022 times 10 to the 23rd particles. Molar heat capacity tells us how much heat is needed to raise the temperature of 1 mole of a substance by 1 degree Celsius or Kelvin. Its units are joules per mole per degree Celsius. This property is especially useful in chemistry because scientists often measure substances in moles. So, what is the main difference? Specific heat relates to how much heat is needed per gram, making it handy for everyday materials and practical situations. Molar heat capacity relates to how much heat is needed per mole, which is more useful in chemical reactions and calculations involving molecules. Another key point is that heat capacity, which is the total amount of heat needed to change the temperature of an entire object, depends on the size or amount of material you have. Larger objects need more heat. Specific heat is derived from heat capacity by dividing by the mass, so it stays the same regardless of how much you have. Molar heat capacity can be calculated by multiplying specific heat by the molar mass of the substance, which is the mass of 1 mole of that material. For gases, molar heat capacity can change depending on whether the gas is heated at constant volume or constant pressure. This affects how much heat is needed for each process. Understanding these properties helps explain why different materials heat up at different rates. It's useful in designing heating systems, cooking, and even in understanding how materials behave in different environments. In summary, specific heat tells us how much heat is needed to raise the temperature of 1 gram of a substance, while molar heat capacity tells us how much heat is needed to do the same for 1 mole of that substance. Both are important in thermodynamics, but they focus on different ways of measuring how substances respond to heat.